Bismillahirrahmanirrahim. This is your lecture number 2 for the macroeconomics course. We are going to start our basic analysis. In the first lecture, we were talking about how the overall changes have taken place in the understanding of macroeconomics over the years. And especially these changes have been driven by these all crises that have been that are continuously occurring in different parts of the world. Specifically the Great Recession that happened in the US. This actually raised so many concerns amongst the people about the ability of economics to predict these all crises. Something similar happened during 1930s when this all a Great Depression happened. At that point of time, Keynes raised a lot of concerns about the understanding and the teachings of classical economics, that if the classical economics or the classical economists were correct, why the world actually went into depression, why many people went unemployed, and why they were not able to get their employment back immediately because of this invisible hand. So it means that what they deduce from that particular happenings, that somehow the markets do not adjust quickly itself. It does it, but it doesn't point. So some similar kind of concerns emerged after this Great Recession of 2007, 2008. Many people questioned the ability of economic understanding and economic laws and economic models about predicting the real kind of crises. And specifically, very big people got very much concerned about it. Like, so for example, as I told you, Queen asked the question that why didn't anybody see this crisis coming? Despite the fact that people have got so many big models and they have got a lot of sophisticated technologies available, why they were not able to predict it. And they found out there are some inherent weaknesses in the models of economics, and they basically they try to correct those all things, and now this new economics is emerging. But somehow we are actually studying about some traditional tools that are used to understand economic behaviors. So if you look at the you recall the basic economic analysis, what does you do when you analyze any kind of happening? Like, say for example, when you look at the market, what do you try to find out? You try to find out the price and the quantity that finally people the price which people finally pay, and the price which finally producers get. Similarly, the quantity which producers produce and the quantity which consumers demand. It's a continuous kind of a interaction between the people as consumers and as producer. When you study market, you try to find out the price which actually is determined and through the interaction between buyers and sellers, and you try to find out that price or quantity at the point where this stops, where this trade stops, or where the both parties get satisfied, or where they basically where the things just reach to some kind of a logical kind of a position. Like, say for example, as perhaps I was giving you the example in the last class, that you want to hire a cab, and now you go and ask that person to take you to a certain place. He demands 500 rupees from you, that if you pay me 500 rupees, I will take you to that place. But you are not willing to take that taxi for 500 rupees. What do you want to do is you want to pay 400 rupees for the same taxi. What will happen? At this particular point of time, no trade can take place. Why not? Because the offer price is different from the bid price. The offer price, the price that you are offering, is the different from the ask price. The person who is selling or who is giving the services is asking for 500 rupees, and you are willing to pay just 400 rupees. No trade can take place in this situation. Where will this trade take place? How you will determine that what will be the price which will make both parties happy? Both parties means the buyer and the seller. Here, the person who want to hire a taxi and the person who is driving the taxi, like the cabbie. Similarly, in other markets, you try to find out that where things stop moving. Like say, for example, when you are in a situation that you are willing to give 400 rupees for a destination and the person is asking you to charge or pay 500 rupees, here the things do not stop. Like they keep moving. Like say, for example, there is a continuous kind of like offering and bidding. Like say, for example, he asks you for some price less than 500 rupees and you just actually bid more. You just like just start like you just show willingness to pay a bit more, and somehow these all things keep happening up to the point where you reach to some kind of a situation where both agree on something. So this is something that you study in economics as static equilibrium point. You are very much concerned about the static equilibria. Like say, for example, when you study about market, when you study about human behaviors, like say, for example, you recall the consumer maximization kind of a situation. At what point a consumer maximizes his utility? What do you think? Where he maximizes his utility? And how we can link this particular kind of analysis to this consumer maximization, utility maximization behavior. Does anybody remember, or anybody wants to answer this question?
Sir, I think the maximum point is the points which are the combination of the utility curve. The points on the utility curve is where the maximization is the highest for a consumer in microeconomics.
What do you think about Magul? What do you think? I was asking you the question, that how can you relate this market equilibrium situation or a static situation where you attain equilibrium in the market to the consumer equilibrium point? Graphically, you can see here that a person is maximizing his utility within available income. It is the the maximum he can attain within his budget line. He cannot go above this, and he does not want to live below this. So he always wants to maximize his utility. But at this point, what is happening? Like if you technically look at this point actually is MUX over PX is equal to MUY divided by PY. Now, this is the point where the additional utility which he gets by spending $1 on X is equal to the additional utility he gets from the 1 unit of Y if he assumes or spends $1 on Y. Now, this is the equilibrium point. This is the equilibrium point, means this is a static point. This is this kind of analysis, and the analysis that I have mentioned you for the market, where you actually try to equate the demand with supply to determine the equilibrium price and equilibrium quantity. This is called static equilibrium analysis. That actually, like say, for example, if you look at the first point on the slide, what does this statics means? Static means causing to stand. Static means what? Causing to stand. Like say, for example, what happens when you look at the market equilibrium here, like say, for example, this is a demand curve, this is a supply curve, and what happened at this point? What happened at this point? This point A.
So point A is where the demand curve intersects with the supply curve.
This is the point where system stops moving. Like here, say for example, if your price is here, what does it mean? That the price is such where you have more supply and less demand. In this particular kind of a situation, market will not stop. Market will actually have got a situation where the producers will bid prices low, and they will ask for low prices, and the consumers will be just demanding more if the prices goes down. So somehow this adjustment will take place, and you will somehow reach to this particular point where you will be attaining the equilibrium. All right. And something similar happens when you are below this equilibrium point. If you are below this equilibrium point, what happens that there is a higher demand than the supply. So what happens is that your adjustments take place, and these adjustments again take you to certain point which basically, which is called the equilibrium point. Now, this is what static. What happens at this point? What happens at this point? The system comes at rest. This is the static equilibrium analysis. Do you remember about the comparative static analysis? Now, assume that you are at equilibrium condition, this point A. What do you think? For how long you can stay on this equilibrium? This is a static point, but you are not going to stay on this point forever. Will there be any change come to this system? Where will there be any new price and new equilibrium quantity in this particular kind of market ever? Or you will always remain at point A? What do you think?
नहीं सर, एक्सटर्नल शॉक्स की वजह से भी हो सकता है किसी भी वजह से.
And that's what happened, like say for example, if you think about the external shocks, and if some shock increases your demand from 1 to 2, now you will have got another equilibrium point where the demand will be equal to supply. Now this equilibrium point A is compared with this equilibrium point B. What is happening at B? At B point, you are producing more quantity. At B point, what is happening? Market is producing more quantity and market is charging higher price. This is called comparative static analysis. What do you do here? You compare two static situations or static points. You compare A with B. Like say for example, the question can be that what will happen in the market and how the market will change its equilibrium if demand in the market increases or supply decreases or supply increases, or both increases together or both decreases together, or one increase and the other decrease. In all of these situations, you will end up on some new equilibrium point. And this new equilibrium point will be your comparative static analysis. Does it make sense to you? If you compare the two static points, this analysis is called comparative static analysis. This analysis is called what? Comparative static analysis. Does this make sense to you guys?
Yes.
Now basically we are moving towards a new kind of analysis, which is very much in line with what actually really happens in the world. You must have heard about it, that there is only one thing constant in this world. Do you know what is constant in this world?
Change, sir.
Change. Only change is constant in this world. एक तगय्युर को सबात है ज़माने में. Nothing else is constant. So everything keeps changing. Everything keeps moving. Your market does not remain in equilibrium for a long period of time. There is always emergence of the variables. Variables move over time. And this kind of analysis is called dynamic analysis. This kind of analysis is called what? Now basically you have got three types of analyses. One is called the static analysis. The second one is called the comparative static analysis. And the third one is called what? Dynamic analysis. What does this dynamic analysis means? Dynamic means something causing to move. Static means causing to stand, causing to bring at rest. Dynamic means causing to move. Like L. Walras defines dynamics as always of interdependence, in which we suppose the data of the problem to vary as a function of time. Like say for example, look at yourself. Your body has all the variables which actually are linked with time. What is happening over time with your body? It is changing. Like, every day you have got some different changes in your body. Like say for example, you from the childhood you enter to adolescence, from the adolescence you enters the young age, and from young age you become adult, and from the adult you become just young, and then become old, and then you basically you die at certain point, and before getting before dying, there are all things basically change in your body. Like say for example, in the young life, when you are young, you run, nothing happens to you, but in some old age when you start running, something that happens, bring you to online class. And it's all about the changes that are taking place in your body. You are not the same all the time. Something similar happens with the world. All the variables are relative to time. That is what basically is a very, very modern analysis. And in this modern analysis, we actually link, or we just always define every variable as a function of time. what happens with every variable, like say for example, what is happening with the population, what is happening with your GDP, what is happening with the price level, what is happening with the quantities of the commodities, what is happening with the technology, what is happening with anything. Everything is dependent or linked with time. Everything is evolving over time. Everything is linked with time. Like, when the time changes, everything changes. Like say for example, the way you are living actually is different from the way you were living 10 years ago. And the way of your living will be different if you somehow remain there for next 10 years. Like you will be having a different kind of a life if you are staying alive till then. You will be observing a new change. You will be observing things basically changing. Everything changes. Environment, population, GDP, country. So I was telling you that the dynamic analysis are generally those analyses in which we assume every variable to be a function of time. And that is a quite realistic assumption, because like whatever you observe around you is changing, is everything is moving, and that movement happening according to the time. Like as the time is changing, everything is changing. Like say for example, you look at your body, look at your age, look at your weight, look at everything on your body, like everything is changing, and something similar is happening. Everything that is happening around us, there is no kind of static things in anything. Like the systems come for a rest for a very short period of time and then again disturbs. Now, what actually this particular L. Walras defines dynamics as analysis of interdependence, in which we suppose the data of the problem to vary as a function of time, with a fixed equilibrium transformed into variable, or what kind of equilibrium? Moving equilibrium. And what is the characteristics of moving equilibrium? It constantly being disturbed by changes in the data and constantly being reestablished. So these things keep happening. Like sometimes your equilibrium, you just go out of the disequilibrium, go out of the equilibrium, you just go into the disequilibrium, and then again this disequilibrium is restored and you again get back to the equilibrium. So comparatively, like if you just compare this dynamic analysis, the static or comparative static analysis, you will find out that how this dynamic analysis is really advanced and really important, and that is more realistic because the markets and every variable keep changing. So equilibrium is something that keep changing, like the things basically keep moving all the time. So this is what something we observed in this particular. And J.N. Keynes, and again this is not J.M. Keynes, John Maynard Keynes is somebody different. J.N. Keynes defined it as a study of manner in which economics and social conditions change over time. All economic and social conditions change over time. Societies evolve over time. Variables evolve over time. Things basically does not remain fixed or constant for long period of time. Things keep moving, things keep changing. Especially study of economic progress, chiefly by historical methods. So dynamic analysis in economics means tracing and studying the specific time pass of the variables, or determining whether given sufficient time, these variables tend to converge to a certain equilibrium values. Like when you do the dynamic analysis, when you do the static analysis, what do you try to do? When you perform a static analysis, what do you try to do? Would anybody like to comment? Like, if you want to, when you do the static analysis, what do you want to do? Yes, Adil?
Study equilibrium.
Yes, you want to know where the equilibrium will be achieved and how, at what point the system will come at rest, and what will be the value of different variables at that resting point. Like, what will be the price at that rest point, what will be the quantity at that rest point, and how the market will be behaving at that particular point. And in that comparative static analysis, what do we do? Like, we basically try to analyze that what happens when some shocks come to the market, and these shocks bring new changes to the equilibrium, and we compare one equilibrium, one static point with another static point. So that is called a comparative static analysis. All right. But in this kind of a dynamic analysis, we are tracing and studying the specific time paths. Now, this particular kind of an analysis does not give you a point. Like, say, for example, in the static analysis, when you talk about the, say, for example, the utility maximization behavior of a consumer, or profit maximization behavior of a producer, what do you get at the end of the day? You get, say for example, if you are making analysis of the consumer equilibrium, you get the amount of consumption X and amount of consumption Y that maximizes the utility of that particular person. And when you do this analysis for producers, you find out the amount of labor and amount of capital that gives you the maximum production. So this is always a certain point at which these two people or these two economic agents achieve certain kind of equilibrium. But what this particular kind of analysis does, what does this dynamic analysis do? It actually traces and studies the specific time paths. It studies and traces what? Specific time paths of the variables, or determining whether given sufficient time, these variables will tend to converge certain equilibrium values. That's what actually is important, that it tries to find out that whether the system converges to equilibrium or not. And when you talk about the dynamic analysis, you must have heard about a situation in your macroeconomics courses about a steady state. Do you know what do we mean by steady state? This steady state is a kind of a situation when things stop growing, stop changing. You always say, for example, steady state of capital is the amount of capital that basically is the same. The growth is the same. That is called the steady state growth. And in dynamic analysis, when this basically happens, you achieve equilibrium. What is happening, say, for example, over the time a variable is fluctuating, it is going up and going down, and that keep moving. That is what basically, this is not something that you are interested in. You want to know whether there will be an equilibrium or not, because if there is no equilibrium, you cannot study any system, because you need to understand, or you need to know the equilibrium point. You need to know the equilibrium of the particular system, at what point the systems or the things basically come at rest. So when you think about a system that is evolving over time, a variable that is evolving over time, if that gets into steady state, steady means
so equilibrium.
Yeah, steady means steady, stationary kind of a thing, not changing, a steady situation.
एक्चुअल में सर
Yes,
सर
yes.
अगर ग्रोथ की बात कर रहे हैं आप, कि अगर 10% ग्रोथ है, तो सर वो एब्सोल्यूट टर्म में तो चीज तो बढ़ ही रही होगी, तो
नहीं,
वो
10%
स्टेडी स्टेट तो सर
जी 10% वो 10% ही रहेगी जी.
नहीं, लेकिन सर अगर हमारी फॉर इंस्टेंस इकोनॉमी थी 100 बिलियन की और 10% ग्रो कर जाती है, वो 110 10% ग्रो कर जाती है, तो 121 की हो जाती है, तो सर वो ग्रो तो इवेंचुअली कर रही होगी टाइम पाथ पे.
नहीं, देखिए वो टर्म में तो ये देखिए ग्रोथ का आपका बिल्कुल कंसर्न सही है. देखिए लेवल चेंज हो रहा होता है, ग्रोथ चेंज नहीं हो रही होती.
जी सर,
समझ रहे आप, आपका क्वेश्चन बिल्कुल सही है. When this particular kind of a situation occurs, your level changes but growth does not change. लेवल बिल्कुल आपका चेंज हो रहा होता है. लाइक फॉर एग्जांपल आपको पता है कंपाउंड ग्रोथ है कि 100 पे अगर 10% होगा तो 110 हो जाएगा, 110 पे 10% होगा तो 121 हो जाएगा, और 121 पे 10% होगा तो 133 हो जाएगा.
बिल्कुल सर.
तो दैट इज अ लेवल. ये 110, 121, 133, they are levels. But what actually is happening that every time that is growing at the same rate. You know what I mean?
Okay sir.
So you will be learning it, and ये growth rate zero होता है. Growth rate का मतलब होता है उसमें growth rate zero होता है, मतलब it's not changing. The growth rate actually, we'll be explaining this, we'll be talking about this. Perhaps at this particular point of time, I'm not able to make a lot of sense with it. But you are, what you can right now learn from it is that the things come at rest. The variables stop moving, stop growing or decaying. Now, they're just moving at the same rate, all the time. All right. So that is what happens. And you try to just find out this equilibrium. And what do we do in the static and comparative static analysis? We assume that the system eventually moves to equilibrium. In static analysis, we try to find out the values of the endogenous variables. You understand the difference between endogenous and exogenous variables, I suppose?
Yes, sir.
Yeah. Can anybody recall for us this endogenous and exogenous variables? देखिए, डायनामिक एनालिसिस में जो हमारे पास जो variables हैं, like वैसे भी system में when we actually have got the variables, some variables are called endogenous and some variables are called exogenous. Endogenous variables are those variables that we determine. Like say for example, when you solve a system of equations, when you solve a like pair of equations, you try to find out the values of x and y. ठीक है ना, आपके पास जो x and y है, they are endogenous variables that you are trying to solve and the value you are trying to find out within the system. और उसी system of equations में you always have got some parameters. इस तरह मिसाल के तौर पर आपके पास एक इक्वेशन है 2x plus 3y is equal to 2 और एक और इक्वेशन है 4x plus 5y is equal to 9. अब इन दोनों इक्वेशंस में x और y जो हैं वो एंडोजिनस हैं और बकिया जितने भी नंबर्स हैं वो एक्सोजिनस हैं. बिल्कुल इसी तरीके से जिस तरह मिसाल के तौर पर अगर एक फार्मर की आप बात करें, फॉर ए फार्मर there are so many things which he determines within the model, like say for example how much water he has to give to the fields, what kind of seeds he has to use, what kind of number of hours he has to spend on cultivation. But what actually comes or determines outside the model? Weather, rains, sunshine, they are all determined outside the model. He cannot influence them. What he can determine through his effort is that how much seed, if he uses, that he can grow his crop. But he cannot determine the sunshine, like say for example, because he will have to take this sunshine as given. Now, say for example, you want to grow or you want to increase the productivity of your land as a farmer. What can you do and what you cannot do? Say for example, if I ask this question from you, that if you are a farmer and you are trying to actually increase the yield of your land, what can you do and what you cannot do? If you want to increase the yield of your land, you can find out the right number of seeds, right number of or right quality of fertilizer, right amount of water that you need to give. But what else you will have to do, you will have to take the weather as given. So if say for example there is unnecessarily high rains or more rains in your area, your field or your crop will be destroyed. You won't be able to control it, despite the fact that you were trying to just increase the yield, that's all will be destroyed, all will be end, all will be finished, if there is so much rain or there is so less rain, if there is so much sunshine or so less sunshine. So that's what basically happens. So in static analysis, we try to find out the values of endogenous variable. Like say for example, when you solve the demand and supply model, when you just solve the demand and supply equations, what do you try to find out?
Price, equilibrium price,
equilibrium
and quantity.
Price and equilibrium quantity. They are endogenous variables. And what do you assume is exogenous?
External factors like income and all other factors.
Yes, very good. So this is what something happens in any of the systems that you solve, have got something that actually are treated as endogenous and some variables that are treated as exogenous. For a demand and supply model, the price and quantity are endogenous, and the income, taste, fashion, weather, and all those variables that you keep constant are exogenous. I hope I am making sense to you guys, right? So in static analysis, when you solve the model, we try to find out the values of these variables, and we try to find out the value of those endogenous variables, and we try to find out what actually will be the values of those variables where the system comes at rest. So contrary to static analysis, in dynamic analysis, what do? We do not find a point where the system comes at rest. Rather, we delineate a time path on the basis of a known pattern of change. Like say, for example, look at this equation number 1. Now, what actually this equation reads for you? Say, for example, dH over dt. Now, what actually I have to define this, what actually this H stands for. But everywhere you should assume that T stands for time. Now, we are assuming that this H is a function of time. This H is what? Is a function of time. And the derivative of this function, the rate of change of this function is T to the power minus 1 over 2. Now, this is a point, this is a growth rate. Now, what are we trying to do? We are trying to find out from this growth rate, the whole path, the whole equation. How can you find out the whole equation from the derivative points? how can you calculate the whole equation,
Sir,
or how can you
I
find
think
out?
we need to take integration into account if we
Yes,
are
very
integrating all the points.
very true, very true. Like, that basically happens. What actually is the situation that, like when you try to find out this derivative, you find out the rate of change at certain point. But this integral or integration of this particular derivative will give you or take you back to the main function. Like, say for example, if you integrate with respect to t, what do you get? You get this bit. How did you get this bit? I'm going to explain you in a moment. Now, this is what basically, and this is the constant that you add to it. Now, what does this show? That this shows the overall time path of the variable h, and h here actually shows the population. The population, you start with initial population, which is a constant. Like, say for example, initially you have got 200 people living in a country, and this population of the country is increasing by 2 into t to the power 1 over 2. Okay, does it make sense?
Yes, sir.
Good. So using integration, we can find out the time path of the population growth rate. And what actually happens in the dynamic analysis here, contrary to the case where we know the function and we find out the derivative, here we have derivative, and what are we trying to do? We are trying to find out the actual function. Now, if you look at this equation, what does this equation read for you? This equation actually explains you the overall time path of this population h, and this h is a function of time. So this h, this population is growing. Like, say for example, you are beginning with h naught, and over the time this h naught is growing with this particular point, this particular value. So this is what something, like that is what basically the dynamic analysis is all about. So what do we do in the dynamic analysis? We try to find out the function, we try to find out the time path, we try to delineate the time path. In case of the static analysis, we try to find out the point where the system comes to rest. But in case of the dynamic analysis, we try to find out the overall function, how the behavior of the equation, or the behavior of the variable over time, that how this variable is evolving over time, how this variable is changing over time. Now, if you look at the explanation of this equation number 2, thus population h at any point of time will in present example consist of the sum of initial population h naught. ये वो constant है that you add when you integrate a function, all right? And another term involving the time variable. That's what is the time variable. So this population example illustrates quintessence of the problem of economic dynamics. That is, given the pattern of behavior of variable over time, we seek to find out a function that describes the time path of the variable. We seek to find out a function that describes what? The time path of the variable. That is very important that you should know. That is something is very important. Now, for the dynamic analysis, if you have got simpler problems, you can use simple integrations, and you can find out the basic functions, and you can basically, like find out that how things are happening and how the variable is evolving over time. But if for the complex problems, you need a further complex equations, and these equations are called differential equations. Does anybody from you have any idea about the differential equations? So we were talking about that, that simpler problems can be addressed with simple integral calculus. But for some advanced kind of situations in macroeconomics or dynamic analysis, we need differential equations. The differential equations are the equations that contain differential or derivatives. आपको पता है कि equations में आपके पास simple variables होते हैं, x plus y is equal to z, or 2x plus 3y is equal to 5, 5x 3y is equal to 5x square plus 2xy plus 3xy, something like that, and is equal to 3 or 4. But if that equations contain the derivative, and specifically the derivative with respect to time or something, like that is called differential equation. That is something we shall be using here. But simply, if an equation contains the derivative, if an equation, like, one of the term in the equation is the derivative itself, Like say, for example, the term, the algebraic term in this particular kind of a equation, one of the algebraic term is the derivative of the variable itself. That is called the differential equation. So these differential equations are important. Before getting on to the differential equations, we need to recall some basic rules of integration. You know, like you understand this sign of integration? This sign? You know, like this is the sign of what? Integration. And this is the sign of
Summation.
जी summation.
Summation.
देखें ये भी summation है और ये भी summation है. समझते हैं आप लोग दोनों को? Can you compare this summation with this summation, this integral? This summation is used for discrete numbers, and this summation is used for continuous number. Like say, for example, what happens when you integrate an equation, when you integrate a function, you find out the area under the curve. What do? You find out area under the curve. And you know, like about these 2 points, say for example, think about the point A and point B. How many points exist between point A and point B? अगर आपको इनको
unlimited points, sir.
Unlimited points, infinite points. इनको अगर आपने sum करना हो तो you cannot use this summation sign. What do you need to do is you actually have to integrate this function. When you integrate, you find out the continuous summation of this particular curve. That is what basically it does. The integration actually helps you. Like say, for example, what does the derivative do? The derivative tell you that what kind of a rate of change of that function is at certain point of time. Whereas the integration basically tells you the whole function. It tells you the overall area under the curve. It tells you about the overall curve. So it gives you the equation of the curve. And this derivative gives you a rate of change of the function at certain point of time. Does it make sense? So look at the basic function of integrations. Now this is the simple function fx dx that you want to integrate. This is actually, you know, like when you integrate this fx dx, you know, like just think about the opposite of it. Like say, for example, when you differentiate this derivative, you get the whole function fx. Like with a small fx, if you integrate that, you get the major function, the main function of x and plus c with a constant. Now look at this x to the power n. When you differentiate x to the power n, what do you get? When you differentiate dy over d over dx, say for example x square, what do you get?
2x x की power 2 minus 1.
G. Now this is the power. Now look at that. If you just say for example, if you have got this and you want to know this, okay, so what happens? Like say for example, this is the opposite of it. The integration is the opposite of it. What happens in the integration or derivative? You multiply the variable with the power and subtract 1 from the power. Now what do you do basically in the integration? You multiply it you divide that with the power plus 1. Here you multiply with the power, and in this particular kind of a situation in integration, you multiply the x with the power 1 plus 1. Like say for example, here you are integrating this x to the power n. So what will you do here? You multiply it with the power. Like say for example, if you are differentiating xn, what will be the derivative of xn?
nx minus x to the power minus 1.
N minus 1.
N minus 1.
Right? Now here basically what are we trying to do? We are trying to find out this n. N is basically whatever is coming into the power. This is 1 less. Right? So we divide it with the power and add 1. Am I making sense? And you also add that,
Yes,
like,
sir.
you know, 1 into the power, and you add 1 constant. And why do you add constant? बिकॉज व्हेन
सर
यू
क्योंकि कांस्टेंट का डेरिवेटिव नहीं होता,
जीरो होता है, तो इसलिए जो
जीरो होता
कांस्टेंट टर्म है उसको हमें इंट्रोड्यूस करानी पड़ती है। जब हम इंटीग्रेट करते हैं तो वी ऐड अ कांस्टेंट टू इट. So I hope you people actually are aware of these kind of things, so you have got idea. So this is the first rule of integration, that what you will do, you will multiply, divide the variable with 1 over the power plus 1, and you will add 1 to the power of that particular variable. This is the opposite of the derivative, exactly opposite of the derivative. Am I making sense to you guys?
जी सर.
Yes sir.
Yes, sir.
Now if you have got e to the power x, you know the derivative of the e to the power x is the, what is the derivative of e to the power x?
So x e to the power x minus 1.
और कोई बताएगा? e to the power x का डेरिवेटिव e to the power x ही होता है, उसको लेकिन मल्टीप्लाई करते हैं हम पावर के डेरिवेटिव से, चूंकि पावर x है तो x का डेरिवेटिव x के हिसाब से 1 होगा, तो उसका जो इंटीग्रल होगा वो भी e to the power x होगा, लेकिन उसके साथ हम ऐड कर देंगे c कांस्टेंट. e to the power x का डेरिवेटिव e to the power x ही होता है, लेकिन we multiply it with the powers, like you know powers derivative, और चूंकि यहाँ पे x है पावर, तो x का डेरिवेटिव x के हिसाब से क्या होता है? 1. So for the simple e
1.
to the power x, the derivative of the e to the power x is simple e to the power x. And if the derivative of that particular variable is e to the power x, its integration will be also the e to the power x plus c. ये आपको recall करने पड़ेंगे सारे अपने rules को. Now if you have got 1 over x, ये 1 over x किसका डेरिवेटिव होता है आमतौर पे? जब हम किसी वेरिएबल को डिफरेंशिएट करते हैं तो हम कब उसको रेसिप्रोकल कर देते हैं, 1 ओवर कर देते हैं? याद है आप लोगों को डेरिवेटिव? जी जी.
-1 की साइन हो या फिर इनवर्स का रिलेशनशिप हो.
लॉग जब हो, देखिए लॉग का डेरिवेटिव 1 ओवर लॉग एक्स होता है. 1 ओवर एक्स यानी 1 ओवर जो है वो लॉग का जो है वो डेरिवेटिव क्या होगा? 1 ओवर एक्स. लॉग एक्स का डेरिवेटिव क्या होगा? 1 ओवर एक्स. लॉग वाई का डेरिवेटिव क्या होगा? 1 ओवर वाई. जो भी चीज लॉग के साथ लिखी होगी वो उसके उस इनवर्स फंक्शन में आ जाएगी. ये लॉग का डेरिवेटिव है. डेरिवेटिव के बेसिक रूल्स अगर आप देखेंगे तो यू विल फाइंड आउट कि e टू द पावर x का डेरिवेटिव e टू द पावर x होता है, और log का डेरिवेटिव क्या होता है? 1 log x का डेरिवेटिव 1 ओवर x, और log y का डेरिवेटिव 1 ओवर y, log z का डेरिवेटिव 1 ओवर z, और log x स्क्वायर का डेरिवेटिव क्या होगा?
टू log x I guess शायद 2 multiplied by log x.
जी 2x की पावर 1 होगा ना. बेसिकली देखिए आप पावर का बेस का
जी, जी.
डेरिवेटिव भी लेंगे और उससे आप डिवाइड करेंगे x स्क्वायर को. 1 ओवर x स्क्वायर मल्टीप्लाई बाय 2x. समझ रही है? याद है आपको? याद आ रहा है कुछ?
सर याद आ रहा है थोड़ा थोड़ा.
वेरी गुड. तो अगर यहाँ पे ये थोड़ा सा टाइपो है, ये x जो है वो f के साथ है, ये x जो है वो किसके साथ है? f के साथ. अगर e की पावर e के ऊपर फंक्शन हो, यानी अभी हमने इससे पहले हम देखा था कि e सिंपल x अगर हो इसके ऊपर, तो x का डेरिवेटिव x के हिसाब से क्या होता है? 1. लेकिन अगर e के ऊपर फंक्शन हो, लाइक से फॉर एग्जांपल हियर, अगर ऐसा हो, e की पावर क्या है? x स्क्वायर प्लस x. समझ रहे हैं आप बात? हाँ भाई, ये जो है
जी. जी.
दिस इज व्हाट, दिस इज दिस. तो अगर आप इसको डिफरेंशिएट करेंगे तो ये तो एज इट इज रहेगा, लेकिन इसकी जो पावर का डेरिवेटिव है उससे मल्टीप्लाई होगा, जो f डैश x है. यानी इसका पावर का डेरिवेटिव क्या होगा? 2x
plus 1.
2x plus 1. वेरी गुड. तो इसके साथ क्या आ जाएगा? e की पावर
x square plus x.
प्लस x. ठीक है, यही चीज सेम यहाँ पे लिखी हुई है. ये जो 2x + 1 है क्या है? ये
डेरिवेटिव।
ये डेरिवेटिव है, ये सही है। और ये x e⁻x² + x है, वो ये है। और इसको डिफरेंशिएट आप करेंगे तो ये सिंपल ये आ जाएगा e⁻x, यानी ये आ जाएगा, ये वाली वैल्यू। इसके ये वाली वैल्यू लिखी हुई है यहाँ पर, समझ रहे हैं आप लोग बात? ये वैल्यू यहाँ पे लिखी हुई है, इसको जब करेंगे तो सिंपल e⁻x² + x आ जाएगा, और कांस्टेंट इसमें ऐड हो जाएगा। Is this making sense to everyone?
यस सर।
जी सर।
सर ऐप की वैल्यू मुझे समझ नहीं आई।
कौन सी वैल्यू समझ नहीं है आपको?
सर ऐप वैल्यू
ये समझ नहीं आया आपको?
सर ई के ऊपर जो एफ है।
देखिए ई के ऊपर तो कोई भी वेरिएबल पावर हो सकती है ना। ई के ऊपर सिंपल एक्स जरूरी नहीं कि ई के ऊपर सिंपल एक्स हो, ई के ऊपर x² + x भी हो सकता है, 2x² + 3x + 2 भी हो सकता है, कुछ भी हो सकता है। लेकिन जो भी होगा वो फंक्शन होगा x का। पहले उस फंक्शन ऑफ x का डेरिवेटिव आप मालूम करेंगे, फिर उसको आप जो है वो उसको उसका जो है वो सिंपल e का डेरिवेटिव तो e ही रहेगा। Is it making sense to you?
ओके सर, थैंक यू।
तो इसको आप थोड़ा सा रिवाइज करेंगे तो you'll be able to do that. It's not a problem. ये हमारी क्लास के बाद जो है ना 2 रेशेवार क्लास ले लेंगे आप लोग।
सर वो जो खुद याद नहीं, हल्का हल्का सब याद आ रहा था।
नहीं याद आ जाएगा बेसिकली, देखें वो सब ये everybody has done this. Look at this particular kind of the function. Look at this. Look at this. If you have got this simple situation, ln x² plus 2x. If you want to know the derivative of this, what will be the derivative of this? What will be the derivative of this? है भाई?
ये थोड़ा टेक्निकल हो गया।
टेक्निकल हो
सर
गया?
2 × log, हाँ 2 × 1/x² + 2 शायद।
देखिए सबसे पहले तो आप क्या करेंगे, इसको 1 ओवर में ले लेंगे। 1 ओवर में क्या आएगा आपके
जी।
पास? x²
1/x² जी
प्लस
प्लस
2x।
2x।
सही है।
2x।
अब यहाँ पे इस x² + 2x का x के हिसाब से डेरिवेटिव ले लेंगे, और वो क्या होगा?
2x + 2।
2x + 2।
जी ये है, ये देखिए ये जो चीज है वो ये है, और ये जो चीज है वो ये है, और ये जो चीज है वो ये है। समझ रहे हैं आप लोग बात?
जी जी, यस सर।
So you should be able to get it. So if you have got some like such kind of a derivative, you can actually when you integrate this, you get the ln fx, natural log of function with some equation which is a function of x plus c. Is this all right?
जी सर ये देखना पड़ेगा प्रॉपर्ली सारा लॉग और नेचुरल लॉग के साथ।
Now differential equations are of very much use these days in all kind of economic analysis for modeling motion and change in all the areas of science and economics as well. Because we are actually borrowing these kind of concepts from other kind of subjects like physics or some other kind of subjects, and where you basically see that how the variables are moving. Like here also we are actually linking the physicists theories to the economics. We are trying to model what? The motion and change in all the areas or all the variables. Like say for example, how your variables are moving. What kind of change is coming into those variables? Like say for example, how your GDP is moving over the time. What kind of change is coming into your GDP? How your population is growing, and what kind of change is coming to your population? What kind of is happening with your productivity, and how your productivity is changing over time. A differential equation, what it does, a differential equation expresses the rate of change of the current state as a function of the current state. A differential equation expresses the rate of change of the current state as a function of the current state. A simple illustration can be this, like say for example, look at this. Now here, just you need to learn the lingo. The language is that you have to know that, like, whenever you have got a dot over the variable some x, whenever you will have a dot over some variable x, that would show the time derivative of that variable. Like say for example, x, the dot over x is showing you dx over dt. Like say for example here, if you have got y dot, what does this y dot would mean? Boliye? What would this y dot would mean?
dy over t.
Dy over
dt.
dt, yes. And how do you read this?
Derivative of y with respect to time.
Yes, how y changes with respect to time. So this actually is function is showing this. Now you have got certain value that you begin with xt, and that is growing with the variable g. All right. So consider the state x of the GDP of the economy. The rate of change of the GDP is proportional to the current GDP. Like, every year, whenever you find out the growth rate of the variables, like, or the growth rate of the GDP, the growth rate of the next year GDP is a function of current year GDP. ऐसा ही होता है ना, कि आप जब ग्रोथ मालूम कर रहे होते हैं तो आप ये देखते हैं कि आपकी जो ग्रोथ है, फ्यूचर की ग्रोथ है, वो आज के हिसाब से कितनी है. तो योर future growth rate, your rate of change of the growth rate is a function of the current state. Am I making sense to you guys? Does it make sense? Where t stands for the time and x over dot t is the derivative of the function with the fx with respect to time. The growth rate of the GDP is x dot over x, dx over dt over x. It's a growth rate. Growth rate में हमेशा क्या करते हैं हम लोग? We divide the rate of change with some basic value. If the growth rate is g, so what you can do is, like, we'll be looking at and how we'll be trying to solve these equations, and the solution will come out as that xt, which is a growth rate of some variable, that how this variable is changing, will be equal to x naught. X naught is a like initial value of that variable, and it is growing to the respect to the power e to the power gt. Do you know this e? What does this e stands for? What does this e stands for? What does this e stand for? I think we'll resume this in the class or sometimes later. My leg is aching quite so much. So if you have got any questions, please do ask and try to recall these concepts. And we shall have got another class before the next class. थोड़ा सा चूंकि 2 breaks में class होगी तो things basically can be covered. ये बड़ी important part है. देखें, that will give you the basic foundations for advanced macroeconomics. If you really want to do some basic advancements, like if you want to learn the advancements in macroeconomics, do these all things very properly. Try to learn them, and do not rely only on the notes I'm giving to you. Try to read a lot of, there is so much open source material available from Yale University, from Stanford, from Oxford, from so many places. Open source information are available about these kind of courses and about these kind of data sets, about these kind of models. So try to learn them. Try to use them so that, like, you will be able to